anybody remember what shape a scrabbula is? Oh, shoot, I just said it. Cubes were scrabbulas, all right? If I do 0, 1, and 2, what will I get for y coordinates? 8. Cube them, 0, 1, and 8. Why did I not plot 3? Because 3 cubed is 27, and I don't want to count 27 boxes. So I did 0, 0, 1, 1, 2, 8. But what do I do on the left side, on the negative side? Yes. Same coordinates, but -1, -1, -2, -8. So we get the other side of the Scrabble there. And then y is doing cube root of x. It's inverse, going to be really easy. Anytime you're doing the root, what do you do to the coordinates? You flip them. So this will, there's not much to flip here. We'll still get 0, 0, 1, 1, but it will be 8, 2. Just flip the coordinates. What will this look like? This is the sideways Scrabble. So 1, 1, 8, 2. And this to me is always the walk like an Egyptian graph. 80 song, they walk like an Egyptian.
Isn't that by the Bengals or whatever it is?
Very possibly. Now, all right, experts, you already told me what's 1 over x and 1 over x squared. Which one's which? There's a hallway.
The squared one and cheeks, right?
Yeah, the second squared one has to have 2 cheeks. So the top one, what do I need to draw first before I draw the curves?
The asymptote.
Yes, the asymptotes. So they both need the asymptotes while I'm drawing them. And then, what one point do I plot on these? Only one. It's where they curve. If there's a 1 on top, you plot it at 1, 1. And -1, -1. Okay, what if there's a 3 on top? It's the same old thing. If it's 1, 1, and if you put a times by 3 on top, you times the y coordinate by 3, so it'll make you plot 1, 3. You always change. Remember, you always multiply the number by the y coordinate, so it would just be 1 over 3 up. It'll make it break for the other asymptote sooner. Because now when I draw it, they're awfully close to the axis. My calibration isn't so hot here, but we'll do okay. And then, so the bottom one, are they side by side on top or on bottom? On the top, because it's positive. X squared is going to make everything positive. So they're both going to be above the x-axis. And what makes them flip? A negative. If it was a -1, then you would be on the bottom too. And you have your cheeks bending over. That's cheeky, all right. Okay, everybody's favorite. Exponential and logarithmic functions, yes. You don't remember what an exponential function looks like? What's it mean? Yeah, thank you. Devin just said, remember, exponential means to grow really, really fast?
Oh, yeah.
So, exponential functions have an asymptote. They only have one asymptote. Where is their one asymptote? X or y-axis? X. Exponential has an x-axis asymptote. They both have an x in them. So, yes, you're going on the x-axis. When you pick your points, let me ring your bells about that one, since we seem to be a little foggy on this. You're putting 0 in for x, so you're going, what's 2 to the 0 power?
1.
Okay, then what's 2 to the first power? 2. And 2 to the second power?
4.
And 2 to the third power? 8. So, in other words, your points, your y's are doubling every time. We went up 1, then we went up 2, then we went up 4, then we went up 8. And if we kept going, it'd be 16, 32, 64. This baby would get big fast. So, logic. How would I do a log with the same base number? They're inverses of each other. Switch the x and y's, take the exact same x and y's we just did and switch them, which I'm doing them up here because there's no graph up here. So the 0, 1, 2, 3 goes down the right side, and we got 1, 2, 4, 8 down the left side. If you recall, I always had you graph an exponential function and its log on this together on the same graph. So we use the same coordinates. In pre-calc, I'm not so nice, but here I'm fairly nice about it. Where is the asymptote? Up and down, yes. And so I'm going 1 over 0 up, 2 over and 1 up, 4 over 2, 8 over 3, and suddenly this is growing extremely slowly, whereas exponentials grew extremely quickly. Do I just dead stop it right there? Where do I go?
You go down the side of the
Yeah, I go down the asymptote. And ta-da! 11 masterful graphs.
That's what I said.
Look, this is the time to stand back and go, ooh, ah, look what I do. There's what?
5 minutes left.
There's 5 minutes left. Is there
Not for
anything?
you now. Oh,
Whoa, where did I throw it? Because that's a trig review. My trig review, or your review sheet, oh well, I lost it. I probably took it over there to fix the computer. But, that's a good